Okay, so this question on identifying oxidizing and reducing agents is just taking it one step further from what we were doing in the last question. So remember, oxidation is the increase in oxidation number, and reduction is the decrease in oxidation number. You may have heard of alternative definitions of oxidation and reduction, such as the very cute little easy to remember mnemonic oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So what essentially is happening is that the electrons that are being lost by the oxidation process are being taken in order for the reduction process to kind of happen. So I just want you to bear in mind that like symbiotic relationship between oxidation and reduction. You don't get one without the other. So, because something that is undergoing oxidation and losing electrons, those electrons that it's lost will then go to cause something else to be reduced. So, if something's being oxidized, it is often referred to as the reducing agent. Okay, so that is the species which causes another thing to be reduced and is itself oxidized. Okay, sounds a little bit confusing. ALEKS actually has a great explanation for this. I love the little analogy they use, which is that it's a little bit like a towel is a drying agent. So a towel, as it is drying something, itself gets wet, okay? And there's a symbiotic process again, because the person who is getting dry, you could look on them as being a wetting agent because they are making the towel wet, okay? So reduction then, if something is being reduced, it itself is the oxidizing agent. So it's a species which causes another thing to be oxidized, while it itself is reduced. So it's the flow of electrons which is, enabling this symbiotic process. I'm just going to put this down here so you can kind of refer to it. So for these kind of questions, again, we have to look at oxidation numbers for everything to determine if it's a redox reaction or not. Then we have to work out what's being oxidized, what's being reduced. The thing that's being oxidized is the reducing agent. The thing that is being reduced is the oxidizing agent. Okay, so calcium is an element, 0. Oxygen, also an element, 0. Calcium oxide, well, calcium will be +2 and oxygen be -2. So that is a redox reaction, right? We have a change in oxidation numbers. So what is done? What? Calcium has gone from 0 to +2. So calcium is being oxidized, which means that calcium is the reducing agent. All right. So what else is going on here? I guess I should probably change color to make this a little bit more easy to follow. So oxygen is going from 0 to -2. Okay, so that is a decrease in oxidation number. Yes, decrease in oxidation number means it is being reduced, which means that O2 is the oxidizing agent. So what are we being asked for over here? The reducing agent is calcium, and write it just as it's written there. The oxidizing agent is O subscript 2, not just like O, it's the whole thing, the O subscript 2. Okay, so let's look at the next one then, do some oxidation numbers, etc. So hydrogen should be +1, sulfide should be -2. You also will get this quick, I promise. Oxygen's an element, so 0. Sulfur is an element, 0. And then H2O, hydrogen's H+, oxygen is O2-. Okay, so let's see what's going on. What's being oxidized? Sulfur's being oxidized. So let me get the right color. Sulfur is going from -2 to 0, which is definitely going to be an increase in oxidation number. Sorry about that. It is the right season in Florida for pollen to be everywhere, trying to kill us. No change there. So this is oxidation, which means that the sulfide ion in H2S is the reducing agent. Okay, and then what else do we have? Let's make that green. So oxygen is going from 0 to -2, so that is a decrease in oxidation number, so that is reduction, which means that this O2 is the oxidizing agent. Okay, so the oxidizing agent is O2. And usually, I believe the convention is to write that the reducing agent or the oxidizing agent, like, I know it's just a sulfide ion in here, but I think you write the whole species to make ALEKS happy. So let's just, I'm actually going to check that real quick, just so you can see the way ALEKS likes it is it's the whole thing, the H2S. So like in the lab for safety, etc. If a bottle has something in it that acts as a reducing agent, you're just going to give like the whole species, the whole compound, if you like. All right, so then the last one, oxidation numbers. Let's go. Sodium +1. Carbon is going to be plus. Hang on, let me actually work this out. It was sodium carbonate, so -6 +2. It's going to be +4. Carbonate, oxygen's -2. Hydrogen will be +1. Phosphorus, let's work it out, -4, so -8 +3. Phosphorus is going to be +5. Oxygen -2. All right, Na2HPO4. Sodium's +1. H is +1. Oxygen will be -2. So let's fill in the phosphorus. -8. -3 would be +5 as well. So there's going to be no change in oxidation numbers for any of this, I think. So carbon +4, -2. Yep. Hydrogen +1, -2. So no change in oxidation number. That is not a redox reaction. All right, so just remember, you have to assign oxidation and reduction numbers to everything. Sorry, oxidation numbers to everything first to work out if it's a redox reaction at all, and then to work out what's being oxidized, what's reduced. And then you can assign reducing and oxidation agents, okay? So don't just go in it gung-ho, okay? Take care, bye.